One of the questions we get asked most frequently is where does our water come from and how does it get to our homes? Well, today we're going to visit a water treatment plant and we're going to get our questions answered by an expert. Mr. Hamill, when I turn on the faucet, I take it for granted that the water is just going to be there. Well, where does it come from?
Well, that's a really good question, Ryan. Our water here comes from a water well. It's a deep water well that draws water from an aquifer. An aquifer is a geological formation that holds water. It's a water-bearing formation. Our water comes from a formation that's about 1,000 feet deep.
Well, I see a lot of equipment in this plant. Are we going to find out what it does?
Sure, we can walk around and take a look at the equipment. I'll explain it all to you. Okay, we're going to start at this piece of equipment. This is our water well. This is what I told you before. It's 1,000 feet deep. Starting right here, there's a hole that's drilled straight down 1,000 feet. We have a pump that's hanging from the top here, and I say hanging, it's hanging on a steel casing from here down to about 500 feet. Now the water well is 1,000 feet deep, but the pump is down about 500 feet. That's because inside that hole we drill 1,000 feet, the water rises up several hundred feet inside the hole, or what we call the casing, so that the pump is below the surface of the water by about 100 feet. So our water rises up to about 400 feet from the surface. Our pump is hanging down about 500 feet from the surface, so it's always submerged.
That's like a giant math problem.
Yes, it is. We do lots of math calculations on the production and the performance of this water well to make sure it's doing well, to make sure it doesn't fail well. Now, the well pump motor sits on top. There's a shaft that connects the well pump motor because the motor is driving the shaft. The shaft goes down 500 feet, so I got a long 500-foot shaft driving the pump down at the bottom. When the motor kicks on, starts turning the shaft, turns the pump, the water rises inside a column pipe until it comes out here. And it goes over here, and it goes inside the ground storage tank.
So when you drill down into the aquifer, there has to be like sand and dirt and all that stuff. How do you get it only the water?
But, when we drill that water well, we do just punch a hole down in there, or so you would think. The water well driller sets a steel casing in his first phase of the construction, and he cements outside that casing, and in this case it's probably down to about 500 or 600 feet. And we put that casing and cement in there to protect from surface contaminations from getting down into the aquifer. Once we set that casing, then they do another drilling process called an underream, where they drill a much bigger hole, and they drill that down to about 1,000 feet. Now they set a liner, what's called a screen liner, where the water comes into the water well. Outside that screen liner is a gravel pack. They actually pump gravel down into the well, down into the formation, so that it comes up around the outside of that screen liner in the underream. Now that gravel pack filters the water as it's passing into the well casing, as the hydrologic forces in the earth push the water into the well. The gravel pack filters out sand and debris and anything else that might be coming in there that's a solid particle that's being held by the water. And then the water comes up into the well pump and comes through into this tank. In this plant's case, that gravel pack is old and it has some issues, and some of the sand that we're trying to keep from coming into our plant still comes into our plant. So we have a sand separator on this plant. The sand separator uses a centrifugal force to spin the water inside there, pushing the heavier particles outside, and then they settle to the bottom. And then daily, we'll flush any sand out, and the sand goes down the drain. Brian, you asked about how does it get to our homes. Well, I said we put energy into the water, and behind us here are the booster pumps that create the pressure. There, if you look, the piping comes from the tanks, the ground storage tanks that we have. The water's being pumped from our water well through that piping that we saw on the other side up into those two tanks. So the tanks are holding the water, and then these booster pumps are taking the water out of those tanks through this piping and putting it into the underground distribution network.
Okay.
That piping starts here and goes out into the subdivisions or out to your home. Behind over here, there's a couple of other tanks that we can talk about in a minute. Those are very key to providing that pressure. Without these, we really couldn't do it. So, kind of to summarize, we have the water comes out of the water well, goes through the piping into the tanks. The booster pumps take it out of the tanks, add pressure to it, and put it into the distribution network so that when you turn on your faucet, the water comes out.
How do you make sure the water you provide is the best and it's safe?
Well, the water that we get from our water well here meets all EPA and state or TCEQ standards. I said once before that we're somewhat lucky because we can pump the water out of the ground and it typically meets all standards. It's not always true for all water sources, but with our water source it is. Now that water that's in the formations below ground in the aquifer, the quality of that water doesn't change very frequently. But we do testing. There is protocol set by the EPA for how frequent we do testing. Some of it we do every day. Some of it we do monthly. Some of it may only be every 4 years or so. But we test the water with a known water source that is very stable in its quality and get those results and put it into a report and send it out to you as a customer to tell you what's in your water. Now, since the water quality doesn't change much, we know that the water quality is safe and it's going to continue to be safe, and we're going to continue to test it. But it's a tried and true water source, so we're comfortable with the fact that the aquifer has got good water.
So you told me that the booster pumps create pressure in the water to go to our homes.
Right.
Well, what if the booster pumps aren't running?
Well, you're right. Sometimes the booster pumps aren't running because we've satisfied the pressure in the system and we don't need to add any more pressure because then we'd overpressurize the system and break the water pipes. Okay, so the booster pumps aren't always running. So how does the water come out when the booster pumps aren't running? Well, in these tanks, these are called pressure tanks or hydropneumatic tanks. Inside the tanks, there's a blanket of air. The top half of the tank is full of air. The bottom half of the tank is full of water. The air pressure is equal to the water pressure below it inside that tank. Okay? Now the air in there occupies a certain amount of volume of the tank. As the booster pumps are running, creating pressure, the water's filling those tanks, creating a smaller space and compressing the air. The air pressure goes up. Right? Now when the booster pumps kick off, that air pressure still exists inside those tanks and it's still pushing down on the water. Okay, so now it's pushing down on the water at the same pressure that it was before the booster pump kicked off. And as it pushes down the water, it creates more volume or more space, and so there's less air pressure as it pushes down. Well, eventually, the air pressure gets so low that the booster pump has to kick back on and replenish that pressure again. So every time a booster pump cycles on or off, the water level in here changes just a few inches, changes that volume of air, changes the air pressure. And that air pressure is what creates the energy that we need to push the water out of your faucet at your home.
That's remarkably simple yet effective.
Very simple.
We have water 24/7, right?
Right.
Well, how do you make sure that there's enough water when there's a higher demand? Let's say in the summer, everybody's running their sprinklers, something like that. How do we always have water?
All right. Well, in the summertime, you're right. The water demand is twice what it is in the wintertime, mostly because people use sprinkler systems. I like to take credit for that as the operator, but to tell you the truth, that's an engineer. The engineer looks at what the capacity requirements for the system are, how many homes we have, what our historical usage is, and make sure that we have tanks that are big enough, booster pumps that are big enough, and most importantly, the source water, the water well, make sure that it's big enough. What I do for him is I accumulate all the information on how much water that we're using, what our peaks are, what our daily peaks are, what our monthly peaks are, so that he can make sure we always have enough water.
My family gets a water bill every month. How do you know how much we use and how much the bill is?
Well, underground outside your home, at everybody's home, there's a water meter. Now every month we have people go through a meter reader, just like your electric or your gas. We read the meters, get the readings, and calculate how much water you've used from the previous month till this month. And then I calculate the water bill and send it out to you. Now that water bill I send you is not just for your water, but it's also for your sewage, sometimes for your trash. And in this area, for the North Harris County Regional Water Authority.
Everybody at home uses a lot of water for the shower, the dishwasher, the laundry, and the toilet. Where does the used water go?
Okay, well, yes, the water comes out of your faucet, and it goes down the drain, and goes down into an underground collection system, what we call a sanitary sewer collection system. That's different from the storm sewer collection system, but we have a separate pipe that collects just the water, the wastewater, that you've used and put down the drain. That flows by gravity and eventually ends up at a treatment plant.
Well, can we look at a wastewater treatment plant?
Sure, we've got one in this neighborhood. Let's go take a look at it.